This movie is for Learning Target 6, Use Angles of Elevation and Depression to Solve Problems in Unit 8. So when we're looking at angles of elevation, we're looking at the angle from the horizontal up. When we're looking at angle of depression, we're looking at from the horizontal down. So you can see here from the horizontal up, this is looking at an angle of elevation, right here being the angle. And then depression, angle of depression is from a horizontal down, and right here being the angle. So this is what we're going to look at in this section. We're going to skip that. If you or have ever been on stage, and you're at center stage here, from point A, this light, we have an angle of, from this light angle down here, we have an angle of elevation down here from the floor up, angle of elevation to the blue light here. We also have from this pole down, we have an angle of depression for this blue light and an angle of depression for this pink light. Suppose a person on the ground right here sees a hang glider at 38-degree angle above the horizontal line. You might be thinking, well, how can you tell the angle of elevation here? And that is because you can use a clinometer, which is actually an app that you can get for your iPhone, for your possibly an Android, and for the iPad. So you can determine this angle using a clinometer. And if, let's say, you found it to be 38 degrees, that we call the angle of elevation because it goes from the horizontal line of sight up. An angle of depression would be the hang glider's horizontal line of sight down. So you can see here that the angle of depression is equivalent to the angle of elevation because the horizontal line here and the horizontal line here are parallel lines, and these are alternate interior angles. You can use the angles of elevation and depression as acute angles of right triangles formed by horizontal distance and a vertical height. Let's take this air balloon. What is a description of the angle as it relates to the situation shown? Angle 1 is up here. This is a bird right here. This is a mountain. We've got the ground. So right here, this angle 1 goes from the bird's horizontal line of sight to the air balloon down to the person in the air balloon. So we say the angle 1 is an angle of depression, and it's depression because it goes from a horizontal down, and it goes from the bird to the person in the hot air balloon. Let's look at angle 4. Angle 4 is down here. It goes from a horizontal line up, so we say angle 4 is an angle of elevation from the base of the mountain to the person in the hot air balloon. How can you tell if it's an angle of elevation or depression? Place your finger on the vertex of the angle, like for angle 4 we would do this. Trace along the non-horizontal side, trace along this side. See if your finger is above elevation or below the vertex depression. So for angle 4, if I'm going this way, you can see it's an angle of elevation. From the bird, this vertex, if I follow my line of sight, I'm going angle of depression. So that's one way to tell if it's elevation or depression. Let's take this example and label for angles 2 and angle 3. Pause the movie, try this on your own, and press play when you're finished. So we see that for angle 2 is an angle of elevation. It's from the person's line of sight to the mountain up to the bird. So we say this is an angle of elevation because it goes from a horizontal up. Angle 3, we say, is an angle of depression because it goes from the horizontal, or the top of the mountain, down to the ground. So from the horizontal down, and elevation is from the horizontal up. Let's use the angle of elevation. Wind farm. Suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. So once I find this height of x, I'm going to have to add down here the height of the person, 5.5 feet. because this right triangle that's formed is not allowing for the height up to the person's eyesight. So I'm going to have to add that 5.5 feet after I'm done solving for x. So we set this up. We see that 56.5 is an angle of elevation because it goes from the horizontal up. So I set that up by doing the tangent function because my opposite side is x, what I want to find, and the side that I'm given is adjacent, 53. So I have the tangent of 56.5 equals x over 53. Multiplying both sides by 53 and typing it in, I get 80.074. Now, we cannot forget that's the height of the eye level, so we're going to have to add the height of the person, which is 5.5, to get 85.5. So the wind turbine is about 85.5 feet from the ground that's down here to the hub up here. You cite a rock climber on a cliff at 32-degree angle of elevation. Your eye level is 6 feet above the ground, so this is a tall person, height of 6 feet. You can see the person here. There's 6 feet. There's eye level. 6 feet over here. Here's the climber on the mountain. And you use that app again. You got 32, an angle of elevation of 32 degrees. What is the approximate height of the rock climber from the ground? So here to solve for x, I've got the angle, the opposite side, the adjacent side. So I know I'm going to have to use tangent of 32. Gives me x over 1,000. Multiply by 1,000. Type that in, I get 624.86. But I cannot forget the 6 feet that I need to add on. And I get 630.86 rounded to the nearest foot, 631 feet. To approach a runway 17 on, City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent. So that means angle of descent is an angle of depression. It goes from the horizontal down. So we're going to go down 3 degrees. Starting from a height of 2,714 feet above sea level. So I can label this height right here. The airport is 1,007 feet above sea level. So it looks like the airport that's right here, I'm going to need to add on a distance of 1,007. To the nearest tenth of a mile, how far from the runway is the airplane at the start of the approach? So in setting this up, I've got my right triangle, and this right here is 1707 because I needed to subtract off my feet above sea level. The plane was able to tell its total feet above sea level, but the airport being on land, it was above sea level, and we had to subtract that off. So I get the 17.07. Here's my plane up here. 3-degree descent. That tells me that this angle is also 3 degrees because these are alternate interior angles. And I'm trying to solve for x. So I'm going to use the sine function because I have the opposite side and I want to find the hypotenuse. So the sine of 3 degrees is 1707 over x, which I'm going to multiply both sides by x and then divide by sine of 3. And I get 1707 divided by sine of 3. Type that in. The airplane is about this 6.177. So it's about 6.2 miles from the runway. I'd like you to pause the movie, try this one on your own, and then input your answers at the end of the movie. And that's all I have for this movie. Angles of